Here we will do a question. Find transfer function of the following state variable representation. X dot is given as this and y is given as this. Okay. So we have the state equation and the output equation. How do you find the transfer function? We have found the formula for it. C into Si minus A inverse B plus D. So first you have to identify what is A, B, C and D. So we know that X dot is equal to A times X plus B times U, and Y is equal to C times X plus D times U. So comparing with the given equations, what you are going to get? A is 0, 1, 0, minus 2 and B is 0, 1. What about C? This is given as 1, 0 and D is not given. So this is going to be 0 matrix. You don't have to worry about it. So first we will try to find Si minus inverse. Okay. So what will be Si minus A? This is going to be S times 1, 0, 0, 1. Okay. Because this is a 2 by 2 matrix, you have to take the identity matrix also 2 by 2. If A was 3 by 3, then what should have taken? 1, 0, 0, 0, 1, 0, 0, 0, 1. This would have been the identity matrix. Okay. So this minus A, which is 0, 1, 0, minus 2. So what you are going to get? S minus 1, 0 and S plus 2. Now how will you find the inverse of the matrix? Inverse is equal to adjoint of that matrix divided by the determinant. So adjoint of this matrix you can write as S plus 2, 1, 0 and S divided by determinant is S times S plus 2. So you are going to be left with 1 by S into S plus 2, 0 and 1 by S plus 2. So now you can find out the transfer function. C into Si minus A inverse B plus D. C is given as 1, 0. Si minus A inverse we have found out as 1 by S into S plus 2, 0 and 1 by S plus 2. And what was B? This was 0, 1. So here you are going to get 1 by S, this into this will give you 1 by S, and then this into this will give you 1 by S into S plus 2 into 0 and 1. This will give you 1 by S into S plus 2. This is the transfer function. The next question we have, the following equation defines a separately excited DC motor in the form of a differential equation. D square omega by dt square plus B by J d omega by dt plus K square by Lj omega is equal to K by Lj VA. The above equation may be organized in the state space form as follows. Find the matrix P. Okay. So now this is the state equation that is given. How do we find the matrix P? Okay. So simply you see this vector here. This will be the state vector. So that means what are the state variables? X of t is equal to x1 of t and x2 of t, which is given as d omega by dt and omega. So that means x1 is equal to d omega by dt and x2 is equal to omega, right? And x dot of t is given here. D square omega by dt square, differentiating this and differentiating this will give you d omega by dt. Okay. Now we have to find P. We know that from the given equation, given differential equation, what do we have? D square omega by dt square plus B by J d omega by dt plus K square by Lj omega is equal to K by Lj VA. We just have to represent or express d square by omega d square in terms of d omega by dt and omega. Then you will get the first row, right? So this is going to be minus b by j d omega by dt minus k square by lj omega plus k by lj Va. This is the first equation. Now what about d omega by dt? This is anyways one of the state variables. Okay. So how we can write the equation in vector form? D square omega by dt square, and here you have d omega by dt. This is equal to, we have to write in terms of d omega by dt and omega. So from this equation here, what can you write? Minus b by j and minus k square by lj plus k by lj Va. So you can now see here d square omega by dt square is equal to this into this. So minus b by j into d omega by dt minus k square by lj into omega plus k by lj into Va. Then what about d omega by dt? This is simply equal to d omega by dt. So you can write here 1 and this will become 0. And this also you can write 0 because there is no relation between d omega by dt and Va given. Okay. So now what was the given question? You have to find this matrix. This is given as P. Okay. So P is equal to minus b by j minus k square by lj 1 0.